Good evening. We have seen about the free body diagram and how we have to draw the free body diagram. We see a problem in detail to understand how the free body diagram is applied to solve the problems. Later on, we can discuss an industrial problem to have a better understanding. It will be a case study based problem. Let's get into the concept. An electric light fixture weighing 150 Newton hangs from a point C. Two strings AC and BC as shown in the figure. Determine the forces in the string AC and BC. This was the question. Here, we have to understand the question first before solving the problem. The system is in equilibrium condition. The light is hanging with the help of these two strings. These two strings maintains this light in equilibrium condition. They are continuously hanging. So there will be some tension acting on the strings B to C and A to C. We have to find the tension in the particular strings to maintain this object in equilibrium condition. So the weight of the object is given as 150 Newton. Here we have to draw the free body diagram first. Here the weight will act downwards. Yeah, we will know that already what we have seen in this previous class. Here the string BC. Since the weight is pulling down, the string will act upwards to maintain the system in equilibrium. So string BC. We can consider name it as TCB. Likewise, the string CA. It also acts on the upward direction to maintain the system in equilibrium condition. TCA. This was the free body diagram. Now we have to think of how we are going to solve this problem. The three force is acting from a concurrent point on three different directions. Can anyone say that what law we can apply over here to solve the problem? Yeah, you are right. It's Lami's theorem. We can apply Lami's theorem to solve this problem. For Lami's theorem, you have to find the angles between the other two forces. You have to find these three forces. Here we have given with two angles, 60 degree over here and 45 degree over here. There are several ways to find the angles. First method, we can draw axis lines like with the four quadrant systems on this point by considering this as an origin. After drawing this, we are able to get a right angle triangle here. Since it's a right angle triangle, it will be of 90 degree. The sum of the angle of triangle is 180 degree. Here it's 60, it's 90. So the other angle will be definitely of 30 degree. 30 degree. So when it is 30 degree, it is 90. Then the sum of this angle is 30 plus 90, 120 degree. So this is how we have to find the angles, 120 degree. Here it is 45 degree. So when it is 45 degree, definitely it will be also 45 degree. Since it is 90 degree, the other side it will be a 45 degree. This shape is like Z. If it is 45, this side will be a 45. 45 plus 90, 135. So this angle will be a 135. So now we have to find this angle. Here it is 45. It is totally of 90 degree. We have already find it as 30. So the remaining angle will be of 60 degree. So 120, 135, or we can subtract this to minus 360 minus 120, 135, or we can have 60 plus 45 as 105. So this angle will be of 105. So we have identified the three angles. Now we can apply the Lami's theorem to solve the problem. Lami's theorem, we know that if the force F1 divided by sine of other two angles. F1 divided by sine theta 1 is equal to F2 divided by sine theta 2 is equal to F3 divided by sin theta. This is the Lami's theorem. Now, by applying this Lami's theorem, we can solve the problem. TCB by sin 135 is equal to TCA by sin 120 is equal to 150 divided by sin 105. So substituting the values in the calculator, we get the value TCA as 134.5949. Similarly, the TCB is equal to 109.81. I already said that while using the calculator, you must have in degree mode for substituting the angles. I have to change the calculator to degree mode before substituting the answers. Then only we will get this answer. Thank you.